All right. So this is lecture 8. My name is Harmtedy Chanda. Then today we're beginning functions. And then under these functions, we're going to be sketching the absolute value functions. This is just a continuation of the previous lecture slide, which was lecture 7. So after sketching the absolute value functions, we're going to also look at how you find the domain and the range of the functions. So we can quickly begin. So there are about 4 important graphs that you need to know. These graphs, you just need to master them. You just need to master them, and they are going to help you to solve other questions. Yeah. So the first one, the graph of the absolute value of x. So what you should understand is you need to know what the absolute value, these symbols, what do they mean and what do they imply? So when you have something like, maybe for instance, y is equal to -1. So when you say the absolute value of this -1, the answer will be a positive number, which is just a positive one. That's the meaning of absolute values. So in other ways, it's just the opposite of that given negative integer. It is not, the opposite is not true. Yeah, the opposite is not true. The absolute value of positive one is not -1. The absolute value of positive 1 will still remain 1. And then unless the absolute value of -1, that's the one which will give you +1. Yeah. So we proceed. So the absolute value of x, when you're sketching the graph, it comes out like that. You can see that is how it comes out. So you need to master this graph. You need to master this sketch. And then these are the domains and the range of the above graph, of this graph here. This is the domain. So the way you find the domain and the range is just the same way we are doing in the previous lecture slide, where sorry, this one was supposed to be an open bracket. Yeah, so for absolute value functions, we should know to say the domain is just the set of all real numbers, which implies that all negative integers and all positive integers inclusive. And then, so now we talk about the range. So finding the range here, you can see it is only on the positive side there, which implies that uh, we're starting from 0. 0 is also part of the set, then up to infinity, meaning we're talking about this area, this side. We're only talking about this area going up, that's the range. And then the range is only measured in the y-axis. Yeah, what of the absolute value function has a negative outside? How does it look, or what does it look like? So in this case, it is going to face down. So this negative here is simply just -1. So this negative is just the same as -1 there. So -1 there is, in other words, some people call it the gradient. So when it has a negative in front there, just know to say it's going to face down. And these are the domains. You can see the domain, like I said, this is also supposed to be like that. It's supposed to be an open bracket. The domain, like I said, for all absolute value functions, you can insert any real number there. You still have you still get a solution for that, except if there is a radical somewhere. So So we talk about the range. You can see that when we talk about the y values there, we only have y values in the negative. We don't have on in the positive. Okay. So let us quickly finish up this. Okay. Sorry. Okay. Yeah, so we proceed. So what if you have the negative inside? Remember what I said, when you talk of absolute value, we're simply talking about the negative numbers being transformed to positive. So the absolute value of negative x will still give you a positive number. So this one, so when you look at this one here, and this one here, there is no difference due to the fact that any number, the absolute value of any positive number will give you a positive number. Here, the absolute value of any negative number will give you a positive number. So meaning this and that are almost the same, are actually even the same. So the graph will not change to just come out the same way as the first one here, to just come out the same way as this one. This is what you're seeing there. The domain and the range will still stand the same way. Remember here, there was a mistake. I just hope that I'll remember, correct this mistake um, after after the lecture, so that as I'm going to be sending the lecture slide, here is going to be an open bracket like that. So proceed. What if you have both inside and outside? There is a negative. Just it will come out as the second one here. Why? Why is it come out? Why is it coming out as this one? Because here as we said here, we said to say the absolute value of any negative number x, you will still give you a positive number. So meaning this one, the only negative that is effective here is this negative outside, which will be like this. So this is the reason why you have seen this curve, this graph and that graph are just the same. So the range and the domains will be the same. So here there's also supposed to be an open bracket. Okay, we proceed. So let us now try to take a look at these examples. We have the first example A, B, C, D up to G. So after doing this, I'm pretty sure, and I'll know, and I'll be sure to say, you guys will be able to sketch any given graph. And there is also an exercise at the end of this slide, which should be requested to answer and submit before Thursday. So the first one here, yes, so the first one here, when you look at this one, we have the absolute value of x plus 1. So how does that come out? It's going to come out as, it's going to be like this. Yeah. So the absolute value of x, we know that it always comes out like that. This is how the absolute value of x comes out. Now, if there is a plus 1 here, there is a plus 1, it simply means that you are going to, if there is a plus 1 there, it simply means that we're going to shift in the y by 1. So we're going to shift by 1 in the y like that. So this is how it's going to come out. Okay? So it's just as simple as this. Then the domain will always be the same as I said, or it's just a set of all real numbers. Yeah, like that. Okay. So from there, The range, you just get this as the lowest number you can see, then going up. We are starting from 1 going up. So starting from 1 going to infinity. So this is the domain and that is the range. I don't know what else is remaining. So here, uh, yeah, so on this one here, this is straightforward. This is how you sketch it. So if you want, you can use this table of values. If you just want to be at least a little bit accurate, you can use the table of values to sketch. You use the table of values to sketch. Then you plug in some numbers there and then you find the answers. So let us now move on to the next question, because this one is done. They are simple. I don't know why most people find difficulties when it comes to answering such questions. Okay, so we move on to this one. So this one is just the same as this. The only difference is that this one is a -2. So if there's a -2, it means that it's going to cut the y-axis at -2 like that. And then it will still face up. It will still face up like that. So at one point, I'm going to show you how to solve these same equations in order to find this value there and that value there. Yeah, even this value there. But for now, I want you to first know this, so that the next, actually, I'm going to show you in the next lesson that we're going to have, since we're going to be solving equations involving absolute value functions, including equations involving the radicals. So this is how it comes out. Now somebody might be asking, how do you find the range and the domain? The domain still remains the same, and then the range, here we have -2, meaning we are going to have -2 going up to positive infinity. It is just as simple as that. Okay. Wow. So we proceed. We go to C. Move on to C. So C is saying the absolute value of x plus 1. So here what you do is, remember what we were doing yesterday on radicals. So you equate this to 0. Then you find the value of x. So the value of x there will be -1. So if the value of x is -1, what do? It simply means that the graph, rather the graph that you are going to draw is going to turn at -1. So -1 this side, and it's going to be like this. Let it go like that. What is the domain and the range? The domain will still remain the same. The range here will be, we're starting from 0 going up. So we're starting from 0. So this is going to be 0. Let me just delete it and write something else. Okay. This is 0, comma, infinity like that. So these questions are just as simple as that. You don't need to stress for you to answer them. All right, we proceed. Let us do y is equal to x minus 3. So for y is equal to x minus 3, you equate your x minus 3 to 0. X minus 3 0 such that your x value will be positive 3, and then this is going to be 1, 2, 3. Okay, so this is where the graph is going to tend. It's going to tend from here. So we draw now the curve. It's going to be like that. Okay. So when you try to replace 0 where there's x, you discover that the value of y will be negative 3. Then the absolute value of negative 3, this is the 3 that you are going to have there. Okay. So what is the range and what is the domain? The domain will still remain the same. The range will start from 0 to infinity like that, still the same. Okay. We proceed. So these questions are very simple and straightforward. I don't know why a lot of people stress when it comes to answering them. They are very simple. Okay. So let us move on to E. So E is saying y is equal to 2x. So that 2 in front of the absolute value of x is just, like I said, some people call it the gradient. So since it's positive, meaning our curve is going to face upwards, it's going to be like that. And then for numbers, rather for functions which have a gradient greater than 1 or less than 1, you normally do what? You normally just use this the table of values where you say you put negative 1, you put negative 2, you put your 0, you put 1, you put 2. So you put negative 1, while there's x there, you still have negative 1. The absolute value of negative 1 is positive 1 times 2 there, you get your 2. You put your negative 2 there, on the absolute value of x, you get positive 2. Positive 2 times 2, you get 4. When you put 0, you get 0, because 0 times 2 still get 0. When you put 1, you get 2. When you put 2, you get 4. So you can put your numbers there. You have 1, 2, 3, 4. You have 1, 2, 3. Okay. Then apart from that, apart from that, we move on to the y. Y we have 2, 4, 0, 2, 4. So you can just put this 2, 4, 2, 4. So you have negative 2, you have negative 4, you have 2, you have 4. Oh, these are negative numbers, by the way. So we say negative 1, comma 2. We have the point somewhere there. We have negative 2, comma 4, negative 2, comma 4. We have the point being somewhere there. So connect it like that to the center. Here on this side you have 0, comma 0 there. Then you have 1, comma 2. 1, comma 2, the point is there. Then 2 comma 4, the point is there. You also connect the 2 points like that. You can even extend it. You have drawn, rather you have sketched. This is E. What is the domain and what is the range? So the domain there is simply the same thing here, will still remain the same. And then what is the range? The range there, the range will begin from where? From 2. Sorry, the range will begin from 0 to just remain as this, just remain like that. Because when you replace 0 there, oh yeah, when you replace the 0 there where there's x, you still get the 0. 0 times 2 to get the 0. So these will still remain like that. Okay, so these questions are just very simple. They are simple. I don't know why people face challenges when solving them. So let us finish the last two and we call it a day for today. Tomorrow we'll be solving equations involving these same absolute values. Sorry, not tomorrow, but on Thursday. And then we will also do quadratic functions. Then we're done with functions. Yeah. So that next week Monday we begin logarithms, and we also do other things. Yeah. So what else? Oh, I mean, which other question here? So we do this one here. So I'm going to do this one, and what I'll do is I'm going to do this F. Then you guys, I'll leave G as part of your exercise. Okay. So we say, I mean, it's saying y is equal to the absolute value of x plus 1 plus 3. So first of all, you need to understand, I mean, you need to equate the x plus 1 to 0. So when you equate x plus 1 to 0, you discover that your x will just be equal to negative 1. So it's going to bend here. Then the gradient is positive, meaning it's going to go up. It's going to be like this, since we have a positive 1 in front there. And then we have a positive 3. So positive 3 is somewhere there. So the cube is going to be bending at this point. So we're going to have something like this. Yeah, so we're going to have something like that. Okay. So this is how we do the sketchings. They are very simple. There's nothing that is so difficult in sketching these things. They are very simple and straightforward. So now I'm going to add G to be part of your, anyway, let me just do it for, at least for clarity's sake. I know some people are asking themselves, how has it done this one? So let me do also G. So G is going to be like this. So we have 2 there, we have positive 2. So it's going to be like that. I'll put 2 there. Then we have, when we get x plus 3, when we equate x minus 3, sorry, to 0, x minus 3, when you equate this to 0, you discover that your x will be nothing but equal to positive 3. So meaning it's going to be at positive 3. So meaning this point is the turning point for our graph. I mean for the lines that we're going to draw. And then, is it going to face up or down? The facing up or down is determined by the sign which is in front. And in this case, we have a negative, meaning it's going to face down. Yes. So when you try to put a 0 where there's x there, you're going to remain with 3. So it's going to be 2 minus 3, which is negative 1. So it's going to cut the y-axis at negative 1. So it's going to be like that. Let me just draw it properly. So this is how it's going to come out. What is the domain and what is the range? Remember what I said, domain will always be the same except in radicals. So it's going to be like this. Then what is the range? So the range in this case is going to start from 2. Actually, it will not start from 2, we'll start with the negative infinity. Start with the negative infinity up to where? Up to 2. This one is not supposed to be this bracket. It's supposed to be this. Yeah, I think we are now done. This was the last question. It is done. So this is the exercise that I prepared for you. I want you guys to do. I've stopped putting many questions because I think most of you are feeling lazy to answer them, and hence you are not submitting your work. So please, for this one, I need it. I need to see how you are, how you are understanding these things, if you have understood or not. All right. Thank you very much. If you have any questions, you can ask. I'm giving you this time to ask questions. Okay. It seems like everyone has understood. So what we're going to do now is that I'm going to end the meeting, and then please make sure that you do the exercise. I'm going to send this slide together with the video, the recorded video for revision sake. And make sure to say that you answer the exercise that I've given you and submit before Thursday. All right. See you in the next lecture.